Hello, I'm Noelle Lim on ASEAN Speaks by Maybank. Joining me in this podcast is Yash Lohia, Executive Director and Chief Sustainability Officer at IVL, or Indorama Ventures Limited, that is listed on the Stock Exchange of Thailand. IVL is a global chemical company, notably a market leader in the production of polyethylene terephthalate, or PET, from raw material to recycling. We find out more about how IVL is changing the value chain and transitioning to clean technology in manufacturing PET, which has a wide spectrum of use, from making bottles, containers, and packaging for food, beverages, personal care products, and other consumer products. Thank you for joining us, Yash. Let's take a bigger picture view first. IVL is building the infrastructure for a circular economy, from raw material to making biomass and recycling. Where are the weak points which could do with more investments and new technology?
A circular economy means for IVL, PET bottles being recycled, going back into PET bottles. What's required for a circular economy for that is a shared value concept of the players in the value chain. We're a resin producer, we produce PET resin, then we sell it to a converter who will process it into a preform, then bottle. Then it gets filled by the brand owners. Then it goes to retail. Then it goes to the consumer. Then it goes to waste management. Then finally it goes to get recycled again. We need good transparency along that value chain of those players so that we can be able to track the bottles going through the process so that it can finally come back and be recycled again. Communication is key. And you do have trade associations, you have consortiums that have representation from the value chain. You need transparency. With a circular economy, you may also want to add more sustainability initiatives. It'll get more expensive for a recycler, for example, to sort it and recycle it rather than landfill it. That cost sometimes needs to be helped out by the government or needs to be shared by the value chain. And then circular economy for us, when you talk about biomass, then we also want to talk about what source of biomass is the right source. Is it sugar? Is it corn? Is it wood? So there are many different options when it comes to biomass. And understanding from the technology players who have these technologies, understanding from the brand owners what they prefer, from consumers, and then also understanding, what technologies does the value chain prefer to use? Because biomass is a very new subject, and that's something we're just starting out on.
What more is needed in order to increase or to incentivize transparency of information?
We're starting to move in that direction. We're starting to have conversations, more meaningful conversations. Earlier the conversations may have just been on a transactional sort of relationship, buying and selling. Now the conversations we're having are deeper in terms of how can we work together to get more bottles to recycle? What technologies are the right technologies when it comes to advanced recycling? What sources of biomass should we use when it comes to using biomass as a feedstock instead of oil? So these are the conversations that are starting to happen, which is definitely going in the right direction. And it's not only with the brand owners, it's starting to be with technology providers, it's with waste management companies, it's with the converters. It'll also be with consumers through NGOs. And as governments also put in policies to enable more collection, then it's also with governments.
Really an all-society approach where you have to just get everyone on board as well as those people who are willing to invest in the technologies, basically in order to drive down that unit cost. Is that what is needed?
People in the value chain have their targets and the brand owners have their targets. But without an honest conversation, the people in the value chain before will not just start spending more money. So we need to have that clarity that there will be a demand for the more money we're spending. And that is the case at the moment. So the cost, that also needs to be included in the shared value concept, or that needs to be talked about at the very minimum. How far will that cost be passed down the value chain?
How much more will costs go up if we are moving towards that ideal model from a PET bottle to a back to a PET bottle?
Today, if I take like a 2-year average, recycled PET that is mechanically recycled is about 30% more expensive than virgin PET. As you move towards advanced recycling, which includes chemical recycling, then that cost can go up a bit more. We don't know that exact cost because there are no commercial plants at the moment that are chemically recycling, but we see that cost would be a bit more. And then when you talk about using biomass as a feedstock instead of oil, then these technologies are very much in the lab scale and very few in the pilot scale. With that, that cost is also quite varied depending on the technology you use and depending on the feedstock you use. If I talk about how much more it costs, we know it's 30% more for mechanically recycled rPET, and it can go up to 80% more when you go for the more expensive options.
In terms of biomass, which is like the front runner, which gives you the yields that you need?
I'm talking about biomass to PET. At the moment, first generation biomass, which means sugar, is used at the moment to make MEG, for example, which is one of the raw materials for PET. However, the concern there is the value chain doesn't want to compete with animal feed. We don't want to fight for the sugar where it's already being used for humans and for animal feed. The same goes with corn. There are newer other technologies, coming about that are using second generation. By second generation, I mean this is really the waste of the planet. It has no alternative use.
And how far are we in this technology in using waste products?
It's very early stage. It's very early stage at the moment. It's there in a very small lab scale at the moment, which is still not a true representation of when it gets built in a larger scale plant. So this biomass can be used to make MEG, which is one raw material, and to be used to make PX PTA, which is the other raw material for PET. Then these raw materials would then be processed to make PET, which will then become bio-PET. This is a strategy to make a PET plastic bottle directly from biomass waste. It's in very early technology R&D development. So we don't know the actual cost. There are only estimates that the technology companies would give. What we know is that it's more sustainable. The carbon footprint drops down by 50 to 80% compared to virgin PET. And that's the main driver to use biomass waste as a feedstock.
Some of your large clients, they do require the use of 50% recycled materials by 2030. Coca-Cola was an example that has been cited. P&G also needs 50% sustainable or bio-based renewable materials. What's preventing customers from going 100%?
Recycled material means that the bottle is either mechanically recycled or chemically recycled. And you mentioned P&G's target, which is maybe even bio-based. So that's bio-based, that's from biomass waste, what I was talking about earlier. What's limiting their targets from being 100% is availability at the moment. Today, there are not enough bottles being collected for recycling. Many bottles still go to landfill, many bottles still go to incineration, and many bottles still don't get collected. It depends on the waste infrastructure and the government policies that that region has. For example, in Asia, a lot of bottles get littered on the river banks where you have many communities living. And because the waste infrastructure is so weak over there, or not there at all, these bottles float sinking to the river and get lost into the river and the ocean. So that's an area where we have to come up with a solution so that these bottles stop going into the environment, but rather get collected back. Europe, you have government policies now requiring recycling rates and requiring collection rates. In the EU, you require 25% rPET content in the packaging by 2025, 30% recycled content by 2030. They have schemes over there, such as the EPR scheme, Extended Producer Responsibility, which enables the waste management companies, the recyclers, to invest more in their sorting and recycling systems. And there is a shared value concept there where the value chain help out with that. In the US today, what we understand is it's more profitable for a waste management company to landfill it rather than spend money to sort it and sell it. So a waste management company in the US would get about $50 per ton to directly landfill that waste. And that's not just PET bottles, that's aluminum cans, that's glass bottles, that's different metals, paper, other plastics. So this is for all waste I'm talking about. It would cost them about $70 per ton to sort it, which means they would have to sell it at $120 per ton to make that same $50 per ton profit. So the way to, help out with that is we see consortiums coming together in the US, which are like trade associations. So you have the PET Coalition, headed by the Recycling Partnership in the US. And this is a consortium that would help enable the waste management companies to sort their waste rather than landfill it. And that's how we're trying to help as a value chain partner. And there's no one solution for all, which is why it takes time and it takes a lot of thinking through. And then when I talk about the value chain, it includes the government, it includes NGOs also to also help consumers understand why we need to make sure PET bottles get collected. Bottles get collected because they have a low carbon footprint, and they have a low carbon footprint compared to glass bottles and aluminum cans. So we want to keep PET plastic bottles in the circulation, but we want to also make sure it gets circulated, meaning it gets collected and recycled.
What about the option of landfilling it, but the bottles are completely biodegradable?
Today there is bioplastics such as PLA, PHA, PBAT. So there are few of these bioplastics available today. And some of them could be used for plastic bottles. The reason these bioplastics at the moment are going to very niche applications is because they're very expensive. So expensive drinks, like maybe ready-to-drink teas or energy drinks, these could be the applications that use bioplastics that also have a lower volume. When it comes to water bottles or soda bottles, the volume is too huge at the moment to be able to use these bioplastics that are out there. When I talk about using biomass waste, that is all the way at the top of the stream. So it's easier to create that volume. Whereas bioplastics, you're kind of growing the plastic.
What do you mean by growing the plastic?
PLA is one of the bioplastics, and that gets made from corn. So corn makes that plastic right away. What I'm talking about using biomass waste is to make the feedstock of the plastic. So first it would be in either powder or liquid form before it goes to be converted, processed to make the plastic. So it is environment friendly, but it's more scalable. You would be able to make bigger plants and therefore start addressing the high volume applications.
Europe has been quite advanced. Why is it Europe has that and say not the US and of course Asia, putting in place the necessary laws and infrastructure? What's the missing ingredient?
Europeans have always been forward thinking when it comes to sustainability. I think we see that in the northern countries over there. They live their life is a lot more waste conscious and sustainable. So the consumers in Europe are generally more concerned and aware of the environmental issues. We do require for the other regions to catch up. We require for the Americas to catch up, for Asia to catch up. The country in Asia that has a very high collection rate is Japan. Japan have a system where they're sorting their waste at home before they throw it into a garbage bin outside the home. And they started doing that in the 90s. And I believe in Japan, you actually get fined if you don't sort your waste at home, which is why there's such a high collection rate. So in Japan, about 95% of plastic bottles get collected and recycled, where the global average is about 55%.
And so, do you think governments need to start imposing fines, penalties, or even carbon taxes if you choose to do landfilling? There is a higher cost to do so.
Yeah, I think taxing consumers will not work anymore. To be able to change the habits of consumers to be environmentally more conscious will not work. What I've also read in surveys is consumers are willing to spend more on a sustainable product, but they're not willing to change their habits for a more sustainable product. To ask a consumer today to start sorting and recycling at home will not work, which is why we have to incentivize the value chain to increase the collection rates. And I mentioned the EPR scheme. The EPR scheme basically helps waste management companies to invest more money in their sorting lines, which then leads to more collection and more recycling.
I'm quite interested in your renewable energy sources. IVL is looking to phase out its energy source from fossil fuel and replacing it with green hydrogen and renewable energy like solar. What's the progress on this?
Today, we still use some coal plants to fire our boilers. We have that only in Asia. And we have a plan to phase out all of our coal plants by the end of the decade. We're trying to speed that up where possible. That coal would then be replaced by either biomass or with natural gas or with renewable energy. Coal accounts for a big amount of our emissions, of our scope 1 and scope 2 emissions. It's necessary that we phase out all of our coal plants over the next 5 to 7 years. On the renewable energy side, we have different approaches to that. In the US and EU, we're looking at large scale virtual power purchase agreements, VPPAs. The way that works is you basically sign up with the developer of a renewable energy field and you commit to a certain fixed price for that renewable energy. When the market price is above that fixed price, then the company has a gain. When the market price is lower than that fixed price, then the company has a loss. There's no capex upfront cost, which is good for the company, but there's an ongoing gain or loss depending on the market price of the power. It's virtual. So we sign up with the developer, which is real, and we commit to an offtake of that solar field or wind farm. So let's say we sign up to 100 megawatts. So we're committed now to 100 megawatts of that field for between 10 to 15 years. That will be done at a fixed price. That renewable energy power we can offset with our actual power at our manufacturing plants. The renewable energy will physically go onto the grid, and this will be new renewable energy going onto the grid. Therefore, it's a new source of renewable energy. But at the same time, the company's manufacturing plants will offset our emissions and replace the same amount with renewable energy. This is how many corporations are approaching their renewable energy because it's a physical way that you're actually providing more renewable energy to the grid, and it can be large scale. So there's a lot of large fields coming up, where we're able to have 2 or 3 deals and really make an impact on our own emissions. The second approach is buying RECs, renewable energy certificates. We do that a little bit in Europe at the moment. For example, our Spain site is fully renewable because we're buying renewable energy certificates. Finally, the third approach is on-site solar panels. Wherever we have space on land, we'll install solar panels. And on our rooftops, we're installing solar panels. But that's much smaller scale.
Do you envisage by, say, 2050, you can go completely renewable? This includes biomass?
Yeah, so our goal is to have 25% of our total electricity consumption coming from renewables by 2030. We have an ambition to be carbon neutral by 2050. That is definitely our ambition. The targets we've gone out to set at the moment is reducing our greenhouse gas emissions by 10% by 2025 and 30% by 2030 from a base year of 2020. And then on the biomass, we also have a target to move 25% of our feedstock from fossil-based to bio-based by 2030. And our recycling targets at the moment is 50 billion PET bottles per year by 2025, which we're doubling to 100 billion PET bottles per year by 2030. Today, we do about 23 billion PET bottles per year.
I'm quite interested in the use of green hydrogen. What's the progress of that?
Yeah, green hydrogen, we're doing a pilot at the moment in Portugal. We have one aromatics plant over there. We're working with the refinery. They're leading the process and they're able to get grants from the government. And because of the grant from the government, it makes the project very attractive economically. It's very small scale. It's a pilot. We're still in the beginning stages of that. There's nothing that's been constructed yet. There's a consortium that's been identified, and we're currently working on that process. But this would only be up and running in 2025. Too early to give any learnings at the moment. As we go through that process, we will certainly learn from it and see how and when we apply it to other green hydrogen projects. At the same time, we're doing another a carbon capture. So carbon capture and green hydrogen, these are like future technologies that we're looking at to help decarbonize the company. Carbon capture, we're also testing that out. It's our largest site globally. What we do over there is want to capture the carbon and convert it into a new material that we're looking at. A portion would be captured and used as a new material, and a portion would be captured and stored. Again, at the moment for that, we're currently talking to engineering companies to work out the designs.
Is the issue right now about scalability and reliability of or stability of the technology?
Carbon capture is there. Carbon capture does exist today, but there are many newer, more modern technologies that have come out recently. So rather than going for an existing technology that is proven to work, we wanted to evaluate, what else is out there. And that's why we're working with engineering companies to help us evaluate different technologies. The cost also varies when it comes to carbon capture.
What are some new technologies that are right now being tested or is being considered?
They use different types of catalyst for carbon capture. I think that's the main difference. And then also the structural design would also be different. The catalyst that they talk about it's available, but to be able to find the right catalyst to make the carbon capture efficient, that is where these technology companies work on their R&D.
Before we end this interview, I'd like to ask, how is this role as Chief Sustainability Officer preparing you for a bigger role in IVL and perhaps succeeding your father one day?
It's I really enjoy the role, Chief Sustainability Officer. I got into the role in 2019. 2019, we decided that we want to put more focus on recycling. So I helped set up the recycling team. I helped build the roadmap and the strategy for recycling, and then helped execute on all that. So now we have a recycling business vertical that manages the recycling business. As I was in the recycling role, I started to gain a lot of passion in the larger sustainability umbrella. So my interest really just peaked, when it came to how can a company like IVL help be more sustainable and be a leader in our industry, continue being a leader by showing the way on sustainability. And at the same time, I wanted to show that the products we make are not bad for the environment as long as they're managed carefully and responsibly. The role today, allows me to get insight into all the products that IVL makes. insight into all the processes that we have, insight into the innovation that we do, because all the decisions we make now are gonna have a sustainability factor to it, including M&A. We do M&A now. We do have a checklist and a questionnaire with sustainability questions. It's important to us to understand what are their emissions, what is their strategy, what's their approach to sustainability. Really, it falls into every decision-making process today. Products to process to people mindset also has to become more sustainable. There's a lot of education that we do internally through webinars in educating on what can we do as employees of the company to be more sustainable. What can we do when we're talking to friends and family around our towns on how to be more sustainable? And how can we educate our friends and family on IVL and how IVL is more sustainable? We also launched our new purpose statement this year, which is reimagining chemistry together to make a better world. And that sentence, that purpose, obviously has a lot of sustainability thought behind it. And sustainability doesn't only mean low carbon footprint, it also means lasting a long time. How can we innovate our products so that they will last longer? I'm not talking in terms of shelf life, I'm talking about in terms of the benefits that these products give to society. Is it a material that is good for the environment, or is it a material that we need to improve on? And we see PET and polyester, when compared to their alternatives, which is cotton or aluminum cans or glass bottles, then we do see that the life cycle analysis, the carbon footprint of polyester and PET is lower. We have to make sure that it stays in circulation and people understand that it is beneficial. And it would actually be the opposite effect would happen. It would be detrimental to environment if these products were banned.
It was a pleasure speaking with you, and thank you so much for your time. Yash Lohia, Executive Director at Indorama Ventures in Thailand. I'm Noelle Lim on ASEAN Speaks by Maybank.